exercise 3. In this in-class exercise, we will solve the problem involving curvilinear motion of a particle and calculating position, velocity, and acceleration using Cartesian coordinates or three-dimension rectangular coordinate system. So just for a quick revision, that if this is the position of the particle in space, then it can be defined exactly using its distance along x-axis, which is called x-coordinate, distance along y-axis, which is y-coordinates, and distance along z-axis, which is z-coordinate. And it can be written as xi yj plus zk. For example, this point can be written as 2i plus 3j plus 5k. So that's how the position vector is defined. And if that position vector changes with respect to time, we can calculate the acceleration the velocity by subtracting the old position from the new position. So in this example, the particle is at 235, and in 2 seconds, particle goes to 548. So particle has traveled some distance along x, y, and z, and we can calculate those individual velocities by subtracting the change in position, which is 5 minus 2, and dividing it with the time, which is 2 seconds, and then 4 minus 3 divided by 2, and 8 minus 5 divided by 2. So those are individual velocities along x, y, and z, which we can write as a vector vxi plus vyj plus vzk. Anyways, this will be very easy once we solve the problem. One problem. So we'll come back to this later, example 2, but we will solve this problem because it's a two-dimension. It has only x and y axis and no z coordinate axis. So let's work on it. So the flight path of the helicopter as it takes off from point A, which is the origin, is defined by the parametric equation x equal to 2t square and y equal to 0.04 t cube meters, where time t is in seconds. Determine the distance the helicopter is from point A and magnitude of its velocity and acceleration when time t is 10 seconds. So we have the equation for the position, and we need to calculate the exact position of the helicopter from A at 10 seconds. And so let's look at this more closely. So this point A is our origin, so that's 0, 0. So we define our coordinate system. We define the positive direction x going right and positive direction y going up. And this is our diagram. And now it's the time to define the position vector for helicopter, which is this vector directly from origin. And this is our position vector r, which can be written as x and y coordinates combination. So let's write down the equation for position vector r for the helicopter. So r is equal to xt I, which is unit vector, plus yt j, which is unit vector along y direction, and its distance is measured in meters here, so this is in meters. Now both x and y coordinates change as per this equation, 2t square and 0.04 t cube. So it's time to substitute them here. So x is 2t square I plus 0.04 t cube j, and that's meters. And we need to calculate the position of the helicopter at 10 seconds. So at t equal to 10 seconds, r is just substitute t equal to 10 here. So when you substitute t equal to 10 here, it's 2 multiplied by 10 square I plus 0.04 multiplied by 10 cube j. And when you simplify it, this is 200 I plus 40 j. How do we interpret this information, by the way? So let's look at it. It means the helicopter has traveled 200 along horizontal axis, along x-axis, and 40 along y-axis. So at that time, the position of the helicopter along x is like 200, and along y is 40 meters. Okay. So that's how we interpret it. But we need to calculate the magnitude of the position vector, that is its distance from point A. So distance from point A is the length of this line here, length of this vector. How do we find the length of this vector? Is by calculating the magnitude of the vector, which is square root of x component square plus y component square, and this is 204 meters. So this is our first answer for position. Next, we need to calculate velocity. So we need to take the derivative of equation 1, apply d by dt, and we get the equation for velocity. So velocity v is equal to dr by dt, which is derivative of this equation, which is 4ti plus 0.12 t square. Okay, and let's call this equation number 2. And once again, at t equal to specific time, 10 seconds, we are calculating velocity. So at t equal to 10 seconds, v is equal to, we need to substitute 10 here. So it's 4 times 10 plus 0.2 times 10 square. So this is 40i plus 12 g. And this is velocity, so it has the unit meters per second. And to get the magnitude of that, because we have been asked to calculate the magnitude, if you read the question carefully, it says calculate the magnitudes. So we need to calculate the magnitude of both velocity and acceleration. So magnitude of this vector v is square root of 40 square plus 12 square, which is 41.8 meters per second. And finally, acceleration is, we need to take the one more derivative of velocity function. So taking d by dt of equation 2, we get acceleration equal to dv by dt, which is equal to 4i plus 0.24 tj. Now, one thing you should notice here is that x component is no longer function of time. That means it is constant, and the unit is meter per second square. At t equal to 10 seconds, we need to calculate acceleration. So we need to substitute, if t is there, we need to substitute t equal to 10. Since there is no t in x component, so it's as is, but since it's here, it's 2.4. So 2.4 j, and this is the acceleration of the helicopter as a vector. And the magnitude of that acceleration is square root of 4 square plus 2.4 square, which is 4.66 meter per second square. That's our third answer. So we have calculated all of the required parameters. So using the given position coordinates, we have calculated position, velocity, and acceleration of helicopter, everything at t equal to 10 seconds. Okay, now it's time to look at the third problem. So I highly encourage you to try this problem yourself, where x, instead of x and y, now we have x, y, and z. So a particle is moving in x, y, z, where x, y, and z as a function of time are given here. And at t equal to 10 seconds, we need to calculate position, velocity, and acceleration. It's exactly the same thing that we have done for the previous problem, except that it has z coordinate. So we also need to consider z coordinate in our vector. So yes, try to solve this problem yourself